Hi everybody, welcome back to Math 8. This is lesson 9.2.3 that we're going to begin today. It's continuation from 9.2.2, which again talks about right triangles. We're going to kind of build on that today, but our focus is going to be on square roots. Okay, and a lot of you guys are familiar with square roots, but we're going to basically simplify them and estimate square roots, because you guys are familiar with perfect square roots, and today we're going to look at other numbers that we can get square roots of. Okay, so your goal today, your objective is that you're going to understand the definitions of square root and an irrational number, and what those are, and you're going to find values of square roots by estimating, by using a calculator, and also by using a graph. Okay. So EQ for today is how can I find the side length, right? And specifically we're dealing with squares, side lengths of squares. So that has been a common theme for this chapter. We're dealing with squares, and if I give you the area of the square, you should be able to tell me what the measurement of the side of that square is. Okay, so let's just jump right into this. It says you have developed a way to decide if a triangle is a right triangle by looking at the squares of the side lengths of the triangle. If you already know a triangle is a right triangle, how can the Pythagorean theorem help you determine the length of a leg or the hypotenuse? Today, you and your team will develop new ways to find missing lengths of right triangles. Obviously not going to be your team, it's just going to be you today. Let's jump right into 9-80. It says Nikita wants to use the area of the squares in the figure at the right to define the lengths of the sides of a right triangle. So if you guys take a look at this diagram here, it's giving you 3 different squares, right? And if you recall, to determine if a right triangle is a right triangle, you'll know that the sum of the 2 smaller squares, how you're going to compare that to the area of the largest square, and see what you guys can remember. And I want you guys to do the following 3 questions on your own, A, B, and C. Okay, so go ahead and pause the video, take as much time as you need. When you're done, come back and check your answer. Okay, welcome back, and at this point you should have been able to find the missing area of that small square, right? Actually, let me reverse a couple of things here. Not that it really matters much, but the area of the small square is what we're trying to solve for. So I'm just going to reverse this. If the area of the small square is unknown, we're going to call that x. Plus the area of the medium square, which is 16, it should equal the area of the large square. So I just have x plus 16 equals 20. If I were to subtract 16 on both sides, I get the area of the small square is 4 units squared. UN stands for units. Okay, and then the next question, question B, says, what are the lengths of the legs of the right triangle? Well, focus your attention back on the diagram now. If, let's take a look at the bottom square, for example. If the bottom square is 16 units squared, right? I don't know, let me make this a little bit bigger here. No, that's too big. Give me 1 minute. There you go. If that one is 16 units squared, that's the area. We know it's the area because it's units squared. Anytime it's to the second power, you're talking about area. That means a side times a side equals 16. And that side has to be the same exact measurement, because that's what the definition of the square is. All 4 sides are the same length. So you're basically asking yourself what times itself equals 16, and it should be a 4. So if that bottom side is a 4, so is the left one, so is the right one, so is the top one, right? All 4 of those they have to be the same measurement. So 4 times 4 is 16. Okay. So if we already figured out that the missing the missing value of the small squared is 4 units squared, by this point you should be able to figure out that the side is going to be 2. Okay, so that's going to be 2 units. And so now the question C says, how long is the hypotenuse, or about how long is the hypotenuse? Are you able to find the length exactly? Explain your reasoning. So you're at this point, you've got this square here with a area of 24 units squared. Now you're asking yourself, okay, what number times itself equals 20? And we know 4 times 5 equals 20, right? But it has to be a number times itself. So we've got a little situation here, okay? Because there is no whole number or integer that will multiply itself and give you 20, right? Because 4 times 4 is 16, 5 times 5 is 25. We need it to equal 20. So we can't have 4 times 5 because that would then be a rectangle. So for right now, we're going to leave that question as is. We cannot answer that because, I mean, not unless we had a calculator or I'll show you in a couple of minutes here how you can estimate that answer. Okay, let's go to 9-81. The following numbers are examples of perfect squares. Okay, if each of these numbers represent the number of square units in a square, what is the side length of each square? And why do you think these are called perfect squares? Go ahead and answer A and B, pause the video, and then come back when you're done. Alright guys, welcome back. So to answer part A, if each of these numbers represents these square units of a square, the side lengths of this square of 36 would be 6, because 6 times 6 is 36. The area of 64, the side length would be 8, because 8 times 8 is 64. 4 would be 2, 16 would be 4, 100 would be 10, 144 would be 12, 121 would be 11, and 225 would be 15. And then question B says, why do you think these numbers are called perfect squares? So if you focus your attention over here to the right side of my screen, I have created some examples of squares here. Oh, actually, this one is not a square. Let me fix that. There you go. That should be better now. That should be a 6 by 6 square. Okay. So if you count the sides of this, that would be 6 blocks tall. This would be 6 blocks wide. 6 times 6 gives you an area of 36 units squared, right? So what shape does this make? It's called a perfect square because when you put all of these blocks together, it makes a square. And by definition, a square is a 4-sided shape that has 90-degree angles, and all 4 sides are the same length. So if you take a look at the one right below it, that square is the area of 4, and it's 2 times 2 will get you 4. This big one over here gives you an area of 225 units squared, because that is 15 times 15. So these all make perfect squares because when you put them all together, and they actually form a perfect square. Okay, let's go to 9-82. To find the side length of a square with a particular area, you use the operation called a square root. The square root symbol looks like that little check mark. It's also called a radical sign. Okay, again, you guys have pretty confident that you guys have heard of square root before, but we're just going to go over it in detail now. It says to find the side length of a square with an area of 81 square units. For example, you would write the square root of 81, and it would read as the square root of 81. Since 9 times 9 equals 81, then the square root of 81 equals 9. And so they give you a diagram here of 81 square units. It's asking you to find the side lengths, and the side lengths would be 9. And in essence, the square root is, you're just asking yourselves what number times itself gives you the number inside, or the radical symbol. Okay, so here in this question is what number times itself equals 81? That would be 9, because 9 times 9 equals 81. Okay, and it says to copy each of square root below. square root expression below and rewrite them as an equivalent expression without the radical sign. Explain your method for finding the square roots of these numbers. Okay, so go ahead and write this out as equivalent expressions. In other words, just answer this the best you can. All right, welcome back, guys. So again, you're just answering the question here, what's the square root of 49? And that would be 7, because 7 times 7 equals 49. The square root of 121 is 11, because 11 times 11 is 121. The square root of 9 is 3, because 3 times 3 is 9. And the square root of 169 is 13, because 13 times 13 is 169. Okay, so that is your method. You're basically unsquaring 49. If that's another way you can think about that. So again, this is something you're familiar with, or you should be, most of you guys. And we're going to, the next few problems, we're going to estimate and ask yourselves, well, what if it's not a perfect square root number, right? Like, what if I asked you, what's the square root of 50? Or earlier, what was the square root of 20? It gets a little bit more complicated. Okay. All right. Let's go to 9-83. It says in problem 9-74, you try to make a perfect square with 24 tiles, and you could not. Why wasn't this possible? In essence, we talked about why that wasn't possible already. Okay, so what I'll do over here is I'll try to create for you a 24 tiles, and we'll try to make a perfect square. So here is 24 tiles. Okay, so you can see I have a 4 by 6. 4 times 6 is 24, and that's obviously a rectangle, right? So what if I change it though, and what if I did this? 5 times 5, could I do that? Well, 5 times 5, 5 by 5 does make a perfect square, but if you recall, that's a total of 25, right? If that's a total of 25, they don't want 25, they want us to use only 24 tiles. So, well, no problem, what if we take one away? Well, let's see what happens if I take one away. Do some editing with these tiles here. So if I take one away, I've got this little step here, this corner that's missing. So that's a problem, right? So there's, as you can see, it's just not going to be possible. So question B says, estimate the length of a side with a square that has an area of 24 square units. Well, in essence, it's just saying, well, let's say, what if I did have a square that has an area of 24 units? What times itself gives you 24? In other words, what's that side length that would be 20? That would give us an area of 24. So I want you guys to pause the video right now and try to just draw a diagram. Just draw a square, and if the area is 24 square units, what is the side length of that square? Okay. Go ahead and pause the video and see what you come up with. Okay. So at this point, you're kind of drawing a square with the area of 24, right? So the size can't be 5, because 5 times 5 gives you 25. So obviously it's going to be less than 5, right? So you're thinking, well, what if it's 4? Well, can't do 4, because 4 times 4 is 16. So at least at this point, we know that this number, whatever the side length is going to be between 4 and 5, right? So instead of calling it 4 right now, you can say it's a square root of 24, right? Because whatever it is going to multiply itself, and it's going to give you the area of 24. But if that confuses you, don't worry about that. At this point, we just know that it's going to be between 4 and 5. And like we said, this 4 times 4 equals 16. If 4 times 4 equals 16, 5 times 5 equals 25. Well, the area that we're looking for is 24. So ask yourself, what number is going to be closer to 24? Is it going to be the 5 or is it going to be the 4 if I were to square those, right? And so obviously 25 is very close to 24. So our number is between 4 and 5. We're probably a lot closer to 5 than it is to 4, because 4 squared is only 16. Okay, so at this point, if you haven't gotten an answer, just estimate. If you did, multiply your answer by itself and see what you come up with and how close is your answer. So for example, if I were to guess it was 4.8, well, what's 4.8 times 4.8? Okay, and you can use a calculator to figure that out. If it's 4.9, what's 4.9 times 4.9? Right, so see what you come up with. Alright, so here's what my calculator gave me. 4.8 times itself is 23.04. 4.9 times itself is 24.01. So 24.01 is pretty darn close to 24. Right? So I think that is a very safe estimate of what the square root of 24 is going to be. Okay, so the square root of 24 is about 4.9. Okay, so in other words, the side length of each rectangle, is going to be 4.9. Because 4.9 times 4.9 is pretty close to 24. It's 24.01. Alright, let's move on here to the next problem of 9-84. This question is asking you to estimate now. So it says, between which two whole numbers is each of the following square roots? To which whole number do you think it is closer? Estimate the value of the of the square root to the nearest tenth. And you may find it helpful to create a list of whole numbers from 1 to 17 and their squares to use with this kind of problem. So at this point, here's what I think you guys should do. It'll be super duper helpful. You're just going to create a number or a list of 1 through 17, like I'm going to do right now. Just do it on a piece of paper. Just write 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 17. Zoom in here. Okay, so 1 through 17, and I want you to actually square this. Right, so pause the video right now. I want you to square each one of those numbers. For example, 1 squared is going to be 1. Let me change this column to red here. 1, 2 squared is going to be 4, 3 squared is going to be 9, and so on and so forth. Go ahead and write this in your notes because this is going to be a very useful tool for you guys moving forward. It is very important that you guys are very comfortable finding a number that's squared and its opposite, the square root of a perfect square. Important that you do that very quickly. Right, so go ahead and pause the video and fill out the rest of these numbers in your notes, please. Okay, so you should have a table in your notes like this. If you don't, go ahead and pause the video right now and copy this down. This is a result of taking the number on the left column, multiplying it by itself, and it'll give you the answer there. So with that logic, if I were to reverse my process and look at the numbers on the right column, if I say what's the square root of these numbers, I should get the answer here on the left column. For example, what's the square root of 289? 17. What's the square root of 81? It's 9. What's the square root of 169? It's 13. So again, very useful. This will save yourself a lot of time moving forward. You got to know these are very common square root numbers. Okay, so use this to answer problems A through G. So we'll go ahead and do A together. A says this, what's the square root of 40? I want you guys to estimate that to the nearest tenth. So the tenth is just that first number right after the decimal. Okay, so the square root of 40 is between what two numbers? Well, if the square root of 49 is 7, the square root of 36 is 6, I know my answer is going to be between 6 and 7. So is 40 closer to 36 or is it closer to 49? Well, 40 is only 4 digits away from 36, while it's 9 digits away from 49. So I'm going to think about it as your halfway point. Halfway between 36 and 49 is what, like 42? 40, yeah, about 42 and a half, I believe. So 42 and a half is a halfway point between 36 and 49. Okay, so the halfway point is that if I took the square root of 42.5, because that's halfway between 36 and 49, my answer should be halfway between 6 and 7, which is 6.5. Right? So if I'm looking for the square root of 40, it's going to be less than the square root of 42.5. So therefore, it should be less than 6.5, because square root of 42.5 is 6.5. And if 42.40 is below that, I would estimate it's probably between 6.3 or 6.4. So to answer question A, I'm just going to say that this is about, and approximately, I'm going to use this that symbol right there. That symbol means it's approximate. It's about I'll say 6.4. Okay. And I want you guys to use the same logic to estimate the rest of B, C, D, E, and F. And when you're done, explain your answers in part G. Go ahead and pause right now. Okay, here are my estimates. And it says to check your answers with a calculator. So before we do that, let's talk about the strategy that I mentioned before. Right? So for B, I have 9.7. The square root of 95 is 9.7. So the square root of 95 is going to be between 81 and 100. Well, 95 is closer to 100 than it is to 81. 95 is only 5 digits away from 100. So ask yourself, what's the halfway point between 81 and 100? Well, it's about 91, right? I think it's 90.5. So 90.5, if I were to get the square root of that, should be around 9.5. Well, because I'm looking for 9.7, or if I'm looking for, the square root of 95, 95 is going to be higher than 90.5, so therefore my answer will be higher than 9.5. So my estimate was, well, 9.7, somewhere around there, right? Because I don't want it to be 9.9, maybe 9.8, because that would be, my answer might be too close to 100. So that's the thought process. Let me just check here our answers with a calculator. We're going to do problem A first. I said that estimate was 6.4. The calculator actually gave me 6.32. So 6.3 would be the more precise answer. Okay, but we were pretty close. So let's look at the square root of 95. The calculator gives me 9.746. So 9.746, we have to round to the nearest tenth, right? So this 6 turns this 4 into a 5. And because I'm rounding to the tenths, well, that 5 turns that 7 to an 8. So technically this should be a 9.8, but 9.7 is close enough as well. Okay, the square root of 3 is going to be 1.73. So I was a little bit off there. Square root of 59 is going to be 7.68. So it should be about 7.7. The square root of 200, I estimated 1.2. It's actually about 14.14. So it's closer to 14.1. And then the square root of 156 gives me 12.4899. So yeah, right about 12.5 should be the answer. Okay? All right. Let's move on to the next problem here. It says to estimate with a graph. Okay, so in chapter 7 and 8, you examine the graphs of various relationships. What would the relationship between the side length of a square and the area of a square look like on a graph? Okay, so the length of the side of the square versus the area of the square. What would it look like on the graph? So it says to use this resource page to complete the area for the side lengths or the table for the side lengths and the areas. And then you're going to graph it, and the question is asking you, does it make sense to connect them? If so, connect them with a smooth curve. So then you're going to answer the rest of these on your own. So this is the last problem for the lesson. Go ahead and click through this resource page. It should look like this. And I want you guys to answer all those questions, pause the video, and when you come back, take a look at the answers that I have for you. Alright guys, welcome back. So take a look at the graph that I have here. I filled in that table, which is very similar to what you should have filled out in your notes from earlier. The only difference is that there is a side length that's blank, right? And it gives you the area of that square, which is 24, but we had already determined earlier that the square root of 24 is about 4.9. So 4.9 times itself should equal 24. Okay. So part of question A asked you, should we connect the dots after we plotted it? Yes, we should definitely connect the dots, because connecting the dots tells you that, or lets you estimate certain values, like in problem D, which we're going to talk about in a minute. So let's jump to question B. It says describe the relationship between the side length of a square and the area of the square. Well, the relationship is the side length squared gives you the area of the square. So you multiply the side length times itself, gives you the area. Okay. How is this the same or different than other relationships you have graphed? Well, in the past you guys have graphed linear equations that were straight lines. This one is obviously not excuse me, not linear. Question C says, how can you use the graph to estimate the side length for a square with an area of 24 units? Does this estimate match your estimate in problem 9-83? Well, if you look at the graph itself, there's a purple point right there. That purple point, if I locate 24 on my graph, I can estimate that the side length, when the area is 24, the side length is just under 5. So you can say it's 4.8, 4.9, but we already know that it's 4.9. Okay, and we're going to use that same strategy to answer question D. So what's the square root of 10? Well, again, that's the area. If the area is 10, to square root it, my answer is right there. The side length is 3 point something. Now, if you look here, that's 3 and 4. And how many tick marks are between 3 and 4? There's 1, 2, and then there's 3. So there's 3 parts to it. So this first one right there would be 3 1/3. This one would be 3 2/3, and then that would be 4. So if this one is 3 1/3, and my point is right there, I'd probably estimate that it's, I don't know, 3.15, 3.2, and doesn't really matter. It's just an estimate, right? So I'd say about 3.2. Square root of 15, again, we're going to estimate what that value is right there. And that value is just a hair under 4, so I'm going to say it's about 3.9. Right? What is the square root of 5? Well, if I were to look at my graph, it's just a little bit more than 2, so I'd say 2.2. And then the last one, square root of 33. I find 33 in my graph, which is right there, and that is just under 6. So it's going to be, I don't know, 5.8 maybe. Okay, and just check your answers with a calculator, see what you guys come up with, or see if your answers made sense or not. Okay, so that's it for today's lesson. To close this off though, in your summary, I want you guys to answer this in your notes. The last question here, it would be from our learning log. Okay, so not really a question, it's just a reflection, you summarizing your lesson. This question right here says, what is the square root? How can you estimate the square root? And I want you guys to write the instructions to do this as if you're explaining this to a 5th grader. Really, the better question is that I want you guys to focus on is, how can you estimate a square root? Okay, so again, pretend you've got a 5th grade little brother or sister or cousin or something, and you're going to explain to that 5th grader how to estimate square roots, what you've learned today. Alright guys, that concludes our lesson. I hope you guys have a fantastic day, and don't forget to shoot me an email or join our Google Meet if you guys ever have any questions. See you later.